Hello friends, in this video we are going to discuss a single phase full wave controlled rectifier midpoint tapped transformer configuration with RL load. Okay. So here we are having the circuit diagram, right? It is same as that of the with purely resistive load. Okay, the only change is the load branch has changed from R to the RL. Okay, so here in the load we are having the inductor. Okay, as we know, the inductor is the element which stores the energy in its magnetic field. Also it releases the energy, okay, in order to maintain the same current or in order to oppose the change in the current. Okay, so here we are having the supply voltage Vs, which is equal to Vm into sine of omega t. It is connected to the primary winding of the transformer. The primary winding of the transformer is having the n number of turns. Secondary winding of the transformer is having a 2n number of turns. Okay. Next, we are using the two thyristors T1 and T2. Next, voltage across thyristor T1 is Vt1. Voltage across thyristor T2 is Vt2. Right. Next, I0 we are having current flowing through the load and V0. Okay. Let us consider the current flowing through thyristor T1 is IT1. Current flowing through thyristor T2 is IT2. Okay. So it is n as to 2n number of turns. Okay. So if the primary winding is having a voltage of Vs volt, at the secondary winding we will be getting a 2 Vs voltage. Okay, so double that of the primary winding voltage, right? Next, so suppose when Vs is positive, that is from omega t is equal to 0 to pi. Okay, so the polarity will be plus here, minus here. So this plus will appear here, this minus will appear here. Okay, so voltage across the primary winding is Vs, right? As this is Vs and it is a n as to 2n, right? So what about the voltage that will be appearing across the full secondary winding? It is a 2 Vs. Okay, so now here it is a Vs and here it is a Vs. Okay, so total voltage will be Vs plus Vs, it is a 2 Vs. Okay, as the secondary winding of the transformer is having a center tapping. Okay, so this 2 Vs will be divided as Vs and Vs. Okay, next, as this is the highest potential point, so this highest potential will appear here. This is the lowest potential point, so the lowest potential will appear here. Okay, so now it is like from this point to this point the potential goes on decreasing. Okay, so from here to here the potential goes on decreasing. Okay, so as the potential is decreasing, so can we say that this point potential is definitely lesser than that of this point potential? Okay, so potential here is lesser than that of the upper terminal potential. Okay, similarly the potential at the center point is greater than that of the potential at the lower terminal, right? So it is a plus here. Okay, so now this is the highest potential point, this is the lowest potential point. Highest potential is appearing at the anode of thyristor T1, lowest potential is appearing at the anode of thyristor T2. So can we say that when Vs is positive, thyristor T1 will be in the forward bias mode, thyristor T2 will be in the reverse bias mode, because its anode is at highest potential, its cathode is at lowest potential. Okay, so anode is at highest potential means cathode will be at the somewhat lesser potential, so definitely T1 will be in the forward bias mode, right? Here the anode is at lowest potential, so what about the potential at the cathode? Definitely it will be greater than that of this potential. Okay, so thyristor T2 will be in the reverse bias mode. Okay, so when Vs is positive, thyristor T1 is in the forward bias mode, so I applied the gate signal to the thyristor T1 only, right? Similarly, when Vs negative, what will happen? The polarities will be reversed. Okay, so when Vs is negative, T2 will be in the forward bias mode, T1 will be in the reverse bias mode. Okay, so when Vs negative, T2 will be in the forward bias mode, right? So therefore we have applied the gate signal to thyristor T2. Okay, at pi plus alpha, that pi plus alpha is in between pi to 2 pi. Okay, similarly from 2 pi to 3 pi, Vs is positive, again we have applied the gate signal to the thyristor T1. Is this clear? Okay, so here alternately we are going to apply gate signal to T1, T2, T1, T2 and so on, right? Now here we are going to discuss the circuit operation one by one. Okay, here one important thing, here as this is the full wave controlled rectifier. Okay, full wave controlled rectifier, so definitely our inductor is getting somewhat lesser time to release the energy compared to that of the half wave rectifier. Okay, so here the load current will be constant, here the load current will be constant, right? Now so let us discuss the circuit operation during different intervals. Okay, so suppose for omega t is equal to 0 to alpha, right? For omega t is equal to 0 to alpha, let us first discuss for very first cycle. This is for very first cycle. Try to understand the meaning of very first cycle. Very first cycle means It is the cycle which is occurring at the very first cycle of the supply voltage. Okay, when the supply voltage is applied or it is turned on. Okay, means when the supply voltage is applied to the circuit, okay, or to the primary winding of the transformer, at that time what will be the very first cycle, that will be, yes, generated or that will be passing through is nothing but your very first cycle. Okay, next, so for very first cycle from 0 to alpha, yes, I am drawing only secondary side, no need to draw the primary side of the transformer. This is thyristor T1, voltage is VT1, thyristor T2, voltage is VT2. This current is IT2, this current is IT1. Okay, now, so here for very first cycle, means before t is equal to 0, the current flowing through the inductor was 0, right? So definitely from 0 to alpha, right, inductor has not, before that inductor has not stored any energy. Okay, so there is a no point like inductor releases the energy. Are you getting the point, right? So before 0, circuit was at the rest position, so current flowing through the inductor was 0. Before 0 I am saying. Okay, so energy stored by the inductor before 0, it was 0. Okay, so from 0 to alpha, what will happen? This inductor will, yes, inductor is not having any energy, okay, to release, right? So from 0 to alpha, what will happen? These two thyristors will be in the off state. Thyristor T1 will be in the forward blocking mode, thyristor T2 reverse blocking mode. Okay, so thyristor T1 will be in the forward blocking mode, thyristor T2 will be in the reverse blocking mode. Okay, one is the forward blocking mode, second one is in the reverse blocking mode. Okay, so now here can we say that both the thyristors are in the off state? So what is the current in the circuit? Yes, current in the circuit will be 0. Okay, so therefore I0 is equal to 0. What is IT1, IT2? Both are 0. So IT1, IT2, I0 all are 0, right? Next, so what is V0? Yes, V0 is also equal to 0 because current is 0. Okay, V0 is also equal to 0. Next, what is VT1? If you check VT1, both the thyristors are in the off state. If you apply KVL to this loop, yes, it is like VT1 is equal to Vs. VT1 is equal to Vs. What is VT2? VT2 is equal to minus Vs. VT2 is equal to minus Vs. Are you getting the point? Okay, but this is valid only for very first cycle. Very first cycle I am saying. Okay, so for very first cycle, how will you the waveform? For very first cycle, yes, the current flowing through the load, it will be 0, right? From 0 to alpha it will be 0 for very first cycle I am saying. Okay, but here during 0 to alpha I have shown it as a I0. This is for continuous cycle, right? Why this is I0 we are going to discuss. You will get an idea after we complete the 2 pi, right? That is a 2 pi to 2 pi plus alpha, right? So for the very first cycle it will be 0, right? What is the I0 for very first V0 for very first cycle? V0 also equal to 0. So for very first cycle V0 also equal to 0. V0 is equal to 0, but this is only for very first cycle. But for continuous cycle it will be negative. For continuous cycle I0 will be, yes, it is a constant current I0. Okay, next, for very first cycle what is a VT1? It is a Vs. Okay, for very first cycle VT1 will be Vs, right? Now here I have shown it as a 2 Vs, right? 2 Vs is for continuous cycle, but for very first cycle it will be a Vs. For very first cycle it will be a Vs. Are you getting the point? Okay, next, at omega t is equal to alpha we are applying the gate signal to the thyristor. Okay, so let us discuss the circuit operation from omega t is equal to alpha to pi. Omega t is equal to alpha to pi. Yes, let us discuss the circuit operation for omega t is equal to alpha to pi. Yes, gate pulse is applied to the thyristor T1. Okay, so thyristor T1 will turn on. Okay, so when thyristor T1 is turned on, yes, current will be flowing into the upper half loop, right? So here current will be flowing, yes, like Vs, T1, load, and again back to the Vs. Okay, so what is Vt1? Yes, we can write Vt1 is equal to 0. Vt1 is equal to 0 volt, right? Next, what is the V0? If Vt1 is 0, V0 is same as that of the supply voltage, right? So V0 is same as that of the supply voltage. Okay, next, Can we say that IT1 and I0 both are same? Yes. Here, but if you check before alpha, current flowing through the inductor was 0. Okay. So after alpha, what will happen? Whether the inductor will allow the sudden change in the current? No. Right. So current flowing through the inductor go on increasing slowly. Okay. So if you check for very first cycle, right? For very first cycle, okay, after alpha, yes, the load current goes on increasing slowly. Load current goes on increasing slowly, right? This dotted one is for very first cycle, right? But for continuous cycle it is a steady. For continuous cycle it is a steady. Okay. Next, so current goes on increasing and after that it reaches the steady value I0. It reaches the steady value I0. Next, after that means indirectly from omega t is equal to alpha to pi. Yes, inductor L goes on storing the energy. Inductor is storing the energy, so polarity will be plus here and minus here, right? Polarity will be plus here and minus here. Okay. Next, what is the VT2, or sorry, what is the VT1? VT1 is 0. What is the V0? V0 is Vs, right? Next, can we write VT2? If you check this, out of these two thyristors, one is in the on state, second one is in the off state. Okay. If you apply KVL to the outer loop, yes, you can get an idea. So VT2 is equal to minus 2 Vs, right? Thyristor T2 is in the reverse bias mode. Okay. So that's why, and one thyristor is in the on state. So total voltage across T2 is nothing but voltage across these 2 points. Okay. So that is nothing but the 2 Vs. Okay. But it will be reverse voltage. So that's why minus 2 Vs. I am saying it as a VT2. Okay. So if you check from omega t is equal to alpha to pi, V0 is same as that of the supply voltage, right? So there is a sudden increase in the load voltage which is same as that of the supply voltage. Okay. Next, I0 go on increasing slowly, means inductor goes on storing the energy. Okay. Next, VT1 will be equal to 0. Alpha to pi, VT1 is 0. Next, after pi, that is from pi to pi plus alpha, what will happen? Let us discuss. From omega t is equal to pi plus alpha. Yes, from omega t is equal to pi plus alpha. Yes, from pi to pi plus alpha. What will happen? Yes, supply voltage is reversed, right? Because Vs is negative, right? So polarity will be minus here, plus here, minus here, plus here, right? So what will happen? This supply voltage will try to circulate current in this direction. This supply voltage will try to circulate current in this direction. But during pi to pi plus alpha, whether we applied the gate signal to thyristor T2? No. So therefore current in this loop will be 0. Okay. Next, as this supply voltage is trying to circulate current in the anticlockwise direction. Okay. If you check at omega t is equal to pi, what is the current flowing through the inductor or the load branch? It is a I0 and it is a positive current, right? Positive current means what? Current was flowing from right to left. Okay. But whether this inductor will allow the sudden reversal of the current? Not possible. Okay. So whatever the energy stored by the inductor from omega t is equal to alpha to pi, inductor will use that energy. Inductor will release that energy in opposition to that of the supply voltage. Okay. So if you check here, after pi, inductor is releasing the energy in opposition to that of the supply voltage. Okay. So even though after pi supply voltage is negative, but then also our thyristor will be in the forward bias mode only, right? Why? It is because the inductor voltage is greater than that of the supply voltage. Also, if you check near to the pi, what is the value of supply voltage? Near to pi, supply voltage value is very, very small, right? Near to pi, the value of supply voltage is very, very small. Okay. So therefore inductor voltage will be greater than that of the supply voltage. And our thyristor T1, yes, mode of operation of thyristor T1, it is a forward conduction mode only. Be careful. Okay. Thyristor will be in the forward conduction mode only. That is from pi to pi plus alpha, right? Next, here, what is the VT1 now? So VT1 is equal to 0 volt, right? If VT1 is 0, what is V0? V0, or if you apply the KVL, it is a minus Vs, minus V0 is equal to 0, right? So V0 is equal to minus Vs, right? So V0 is negative, but it is same as that of the supply voltage. Okay. Next, what about the I0? Inductor is releasing the energy, but here inductor is having a high value, right? Inductor is having a high value, right? So that's why if the inductor value is lesser, so due to that what will happen? During pi to pi plus alpha, inductor current go on decreasing. But here we are having inductor is a high value, and if you check this comparatively, this time period, this interval is also very small. This interval is also very small. Okay. So definitely, yes, inductor opposes the supply energy from omega t is equal to pi to omega t is equal to pi plus alpha. Okay, so again inductor is having a high value, due to that the current flowing through the inductor, which is equal to load current, that will be maintained a constant. Okay, so here pi to pi plus alpha, I0 is constant. Is this clear? I0 is constant. Next, so during pi to pi plus alpha, V0 is minus Vs. Next, I0 is I0. What is Vt1? Vt1 is 0, right? So I0 is constant, that is I0, right? And Vt1 is 0. Okay, Vt1 is 0. Next, from pi plus alpha to 2 pi, what will happen? Let us discuss. From pi plus alpha to 2 pi. Yes, from omega t is equal to pi plus alpha to 2 pi. Pi plus alpha to 2 pi. Yes. So at pi plus alpha, we are applying the gate signal to thyristor T2. Okay, thyristor T2 is turned on, right? Now thyristor T1 will turn off, because once this thyristor turns on, yes, this full voltage will appear as a reverse voltage for thyristor T1. So thyristor T1 will immediately turn off. Okay, so thyristor T1 will be in the on state only from alpha to pi plus alpha. After pi plus alpha, thyristor T2 turns on. Okay, so current starts flowing from Vs, T2, load, and again back to the Vs. Means in this loop the current will be flowing. Okay, so here load inductor goes on storing the energy. Load inductor goes on storing the energy. Okay, so now during this interval, if you check, yes, what is the Vt2? Vt2 is 0. Vt2 is equal to 0. Okay, what is the V0? Right? If you check, apply KVL, minus V0 plus Vs is equal to 0. So V0 is equal to Vs. V0 is equal to Vs. Are you getting the point? Okay. Next, if Vt2 is 0, what about the Vt1? Yes, thyristor T1 is in the reverse bias mode and one thyristor is in the on state. So what is Vt1? We can apply KVL to this loop and we will be getting it as a minus 2 Vs. Right? Vt1 is minus 2 Vs during pi plus alpha to 2 pi. What is the current flowing through the load? Current flowing through the load is constant because inductor is having a high value. Okay, so it is a I0. So if you check from pi plus alpha to 2 pi, V0 is Vs only. Okay, I0 is constant current. Okay, and what is the Vt1? Vt1 is 2 Vs, but it is a negative, so it is a minus 2 Vs. Okay, so now pi plus alpha 2 pi, inductor has stored the energy. Okay, now after 2 pi, what will happen? That is from 2 pi to 2 pi plus alpha. From omega t is equal to 2 pi to 2 pi plus alpha. 2 pi to 2 pi plus alpha. Yes, from 2 pi to 2 pi plus alpha, what will happen? Yes, supply voltage is positive now, right? So it is a plus here, minus here. Here it is plus and here it is minus. Okay, supply voltage will try to circulate current in this direction. This supply voltage will try to circulate current in this direction. Okay, but whether this inductor will allow the sudden reversal of the current? No. So whatever the energy stored by the inductor from pi plus alpha to 2 pi, inductor will release that energy. Inductor will release that energy in opposition to that of the supply voltage. In opposition to that of the supply voltage. Means even after 2 pi, supply voltage is positive, but then also our thyristor T2 will be in the conduction mode only. It will be in the forward conduction mode. Thyristor T2 will be in the forward conduction mode. Okay, so here we can write T1 forward blocking mode, T2 forward conduction mode. Okay, forward conduction mode. Next, what is Vt2? Vt2 is equal to 0, right? What is V0? If you check V0, apply KVL to this loop, plus Vs plus V0 is equal to 0. So V0 is equal to minus Vs. Okay. Next, what is Vt1? Yes, Vt1 is equal to, if you check, this thyristor is in forward bias mode. Okay, and this thyristor is acting as a short circuit. So Vt1 will be 2 Vs. Vt1 will be 2 Vs. Or you can apply KVL to the outer loop. It is a plus Vs plus Vs. That is a 2 Vs. Minus Vt1 is equal to 0. Okay, so Vt1 is 2 Vs. Are you getting the point? Okay, so from 2 pi to 2 pi plus alpha, 2 pi to 2 pi plus alpha. Yes, what is the V0? It is a minus Vs. It is a minus Vs. Okay, next, what is the I0? If you check I0, it is a constant current. It is a constant current because inductor is opposing the change in the current by releasing the energy. Okay, so that's why the current maintained will be constant. Next, this is 2 pi to 2 pi plus alpha. Vt1 is 2 Vs. This is 2 pi to 2 pi plus alpha. Okay, so if you check 0 to 2 pi is nothing but the one complete cycle. Okay, of the supply. and after 2 pi, yes, we are having the next cycle of the supply. Okay, so can we say that the interval 2 pi to 2 pi plus alpha is nothing but 0 to alpha, right? So interval 0 to alpha and interval 2 pi to 2 pi plus alpha both will be same. Okay, so whatever the waveform we are having between 2 pi to 2 pi plus alpha, the same waveform will be repeating from 0 to alpha, right? So it is a negative here, so that's why here we are having the negative in the continuous cycle, right? Definitely for very first cycle it will be 0, but for continuous cycle it will be negative, right? Next, 2 pi to 2 pi plus alpha current here is constant. Okay, so therefore between 0 to alpha the current is constant for continuous cycle. Is this clear? 2 pi to 2 pi plus alpha, Vt1 is 2 Vs, therefore between 0 to alpha Vt1 should be 2 Vs. Is this clear? Okay, so in the RL load, okay, and generally in the single phase full wave rectifiers, in the RL load, yes, we will be getting the constant current. Most of the times we will be getting the constant current because the inductor is getting very lesser time to release the energy. Okay, and that time is lesser. The time is what? The time corresponding to pi plus alpha, time corresponding to 2 pi to 2 pi plus alpha, time corresponding to 0 to alpha, right? So during that interval inductor is getting very lesser time to release the energy. Okay, so time is lesser means what? Yes, the current is constant, right? So therefore inductor energy is greater than that of the supply energy, so that's why inductor is successfully maintaining the constant current. Is this clear? Next, one more thing, if you check the circuit operation from alpha to pi plus alpha, yes, thyristor T1 is in the on state, right? Pi plus alpha to 2 pi plus alpha, thyristor T2 is in the on state. Is this clear? Okay, so this is about the circuit operation of RL load, single phase full wave control rectifier, center tapped transformer configuration. In the next video we are going to discuss the derivations of this circuit. Thank you.